Hello everyone. In this second tutorial of the series on fire and smoke with a fluid simulator in Blender 4.5, we'll see how to set up the basic material in order to render fire and smoke in cycles. We'll examine the principal volume shader and the two modes, emission and blackbody, that this material provides. As mentioned in the introductory video of this series, the PDF version of this and other episodes is available for free download at the link you'll find in the description. I'm picking up from the scene used at the end of the previous tutorial, but this time I've saved the Blender file and set up a cache folder inside the same directory where the project file is located. As for the material for fire and smoke, it should not be defined for the flow object or objects in the scene, but for the domain. So I select the domain, add a shading editor to the interface, switch to rendered view mode, and create a basic material. I set the strength of the background to 0 in the World tab to make the flames stand out. Playing the animation, we won't see anything yet, because the principled shader created with a default material is not suitable for a volumetric material. I remove the principled shader and insert a principal volume shader, connecting its output to the volume input of the material output node. Even now, when playing the animation, nothing shows up in the rendered preview. So let's see how to give the flames some color. Blender provides two different approaches to flame coloring. The first one is called emission. It is not physically accurate, and at first, its result is quite disappointing, but in reality, it gives us great flexibility in managing both the intensity and the colors of the flames. We'll come back to this mode and its uses in much more detail in a later episode. The second approach is called blackbody, and this one is physically accurate, especially if the strength is set to 1 and an appropriate temperature value is chosen for its field. With this tool, we can immediately appreciate a nice flame in the rendered preview. The temperature value is expressed in Kelvin, and online you can find many examples of real-world values and their corresponding flame colors. Before continuing, I enabled denoise for the render preview in the Render tab. In physics, a blackbody is an ideal object that absorbs all electromagnetic radiation and re-emits it with a spectrum, which we'll simply call color, that depends only on its temperature, regardless of the material it's made of. As the temperature increases, it shifts from the red of a glowing stove to yellow-white, and increasing further, the color tends toward blue. In fact, the stars that have the highest surface temperatures are actually blue-white giants. Regarding the intensity and temp parameters, the first has an intuitive meaning and, as mentioned earlier, 1 is a physically realistic value for intensity, while a value greater than 1 will make the fire brighter, though not physically accurate. The tint field lets you change the color of the flames. Of course, this is not a physically accurate representation. For that, you should rely on the temperature value and leave tint set to white. However, if you want to quickly create colored flames without setting up nodes and parameters with emission, then this option may be useful. At this point, you're probably wondering how to add inflow objects with different flame colors, since the color is defined in the domain material, not in the inflow objects themselves. There are basically two options. The first is to create separate domains, but that only works well if the flames don't need to interact with each other. The second solution is to use parameters and attributes from the emitter objects to try to give their flames different colors, but this doesn't always work well. We'll look at a possible solution in a later episode, after covering the other object parameters and principal volume in more detail. At the top of the principal volume node, you'll notice a field called Color, with a default gray color. This is the smoke color, since principal volume allows us to define both the appearance of smoke and flames within a single node with distinct parameters. The density value also refers to the smoke. To show you the smoke, I set the world background strength back to 1. The scattering of light through smoke particles can be adjusted using anisotropy and absorption color. Anisotropy lets you influence the direction of scattering, which can occur more backward or forward depending on whether the value is negative or positive. To make the differences easier to notice, I increase the smoke density by setting the density value to 2 and frame the object so that the flames are behind the smoke. The absorption color field obviously lets you give a color tint to the absorption of light by the smoke. To talk about the attributes available in the node, I first need to explain some of the information stored by the domain, so we'll stop here for this episode. What we've seen is just the beginning of defining the appearance of fire and smoke during rendering, but between the previous episode and this one, you already have the basic knowledge needed to create and render some flames. In a few episodes, we'll also analyze the other tools provided by materials, especially for using emission, but first we need to cover some other basics of the simulation to better control flames and smoke. That's it for this tutorial. If you enjoy my content, the best way to thank me is to subscribe to the channel and leave a like on the video. Thanks, and see you soon.